is much more misleading. I'll come back to that point a little later. Today, the issues that we face in space research are not of fundamental in nature. They are more applied in nature. So this is something that we need to understand. There are, of course, fundamental issues that need to be solved, but ISRO is not into fundamental scientific problems or fundamental understanding of rocketry or fundamental understanding of space technology or mission management or satellite. I think all of these are already available. But what we need today is innovation. There is a big difference between these two. I think all of you understand that. To work on the current knowledge and produce something which is slightly above the world knowledge today. To do that incremental improvement so that we stand on merit in comparison with others. It is required in many, many areas. It is required in rocket propulsion and technology, where we are looking at how to improve the propulsion capability of solid and liquid, do a little more mathematical modeling, bring better predictability of the performances of systems, optimize systems so that we can build it much better. In every domain, structures, thermal, propulsion, materials. Material study becomes one of the key areas because we are looking at exotic materials for many of the manufacturing of systems. Possibly, ISRO is one of the organizations which has made maximum number of alloys, all varieties of alloys using our Indian ecosystem and converted most of the import content into Indian products. This area we have a huge demand in metallurgical understanding. Process metallurgy is a very important domain to improve production cycle and then bring about production and cost of production. We also have issues in various domains like bringing down the cost of rockets by reusability, which involves understanding materials for reusability, bring the technology of reusability into the day-to-day practice of rockets, bring like vertical landing, bring the aircrafts, high temperature materials, fault diagnostics of materials to understand health management of structures and components, etc. We also want to understand the improvement in manufacturing processes which will reduce cycle time. For example, we have issues of additive manufacturing in a big manner into rocket systems, engines, production, etc., which also produce a lot of problems in terms of manufacturing approaches. Manufacturing itself is a huge topic where we have huge amount of expertise in cold forming, welding, processing, brazing, diffusion coating. I think our domains of manufacturing in special manufacturing processes are very, very strong, and we would like to connect in these areas as well. We have very strong requirement in terms of polymers, chemicals, paints, adhesives. You name anything in non-metallic materials that we use here. We have huge amount of demand of synthesizing components and materials for our use. Our chemical team is very strong in this area. Look at software. I think the softwares that we develop are of varieties of nature, starting from the basic softwares that are required for computation, which includes computational fluid dynamics tools, thermal analysis tools, mission management tools, trajectory optimization tools, simulation tools. Then it comes to applications that we have physical data interpretations, inversion, mechanism, processes, image processing, artificial intelligence, checkout of systems, in all sorts types of software that you can ever imagine. We also make our standard tools as a general purpose tools for use by designers. So we develop structural analysis like finite element tools, which are used across. We develop high computational capability CFD tools, which are very user friendly, and we have been sending to academic institutions to co-develop these tools for our use. So software is a very, very important domain, and we want to expand this substantially. Yet another domain is sensors. I think possibly you may know sensor technology is a very, very complex area in all sorts of sensors. You can name it. We have been importing sensors quite a bit from the very past, and slowly over the years, most of the sensors that we use in our rockets and satellites are now made in India. You name the sensor, everything is there. For example, you look at the inertial sensors, accelerometers of very high quality, gyroscopes, optical sensors, star sensors, earth sensors, sun sensors, vibration pickups, pressure sensors, temperature sensors of various types, of all ranges, speed sensors, in various technologies in terms of MEMS or the physical sensing, all the processing electronics, right from low frequency to high frequency processing. All of these are done within India today, using the technologies developed in institutions like IITs, IIScs, and transferred to industries and being produced in industries for our own use. The indigenous content in rockets and satellites have been growing over the last many years. Rockets started with almost 50% of import content. Today stands at only 10%. Less than 10% is only imported. And that too only high-end electronics like processor chips, RFPGAs or some memories or radiation hardened devices. That's the only thing that we import. Everything else is sourced from India. You may wonder even cables and wires used in our electrical wiring was originally imported, but we indigenized all of this in India. Today, Indian companies manufacture and export for the world market of rockets and aircrafts. Connectors, electrical connectors, you imagine it looks like a simple thing, but it was never manufactured in India. And we helped industries to manufacture in India for the first time. Today, we are the world's highest exporter of high quality electrical connectors used in aircrafts and rockets. I think it's exported from here. Mechanical contact relays. There are so many materials and devices, resistors, even wire mount resistors, strip resistors, or even those things were not originally manufactured in India to the space quality. And we could connect with industries and develop them. So they became the exporters. You may not even know that even nuts, bolts, and screws were all imported for a rocket building and satellite building. Even now we import certain numbers. But over a period of time, Indian companies were developed, we worked with them. And today, the high-strength materials, the manufacturing process, etc., are of world standard that are done in India. Today, we are exporting those fasteners and importing in the brand name of a European and American country, actually manufactured in India. So this is the transmission that we have created by working with industries and academics over the many years. And many people ask, are you doing it in India itself, or are you importing many things from outside? This is a constant question I hear. I think I tell you, our Indian people are as competent as you are in Europe or America. Only thing that we don't have certain resources that allow us to work on the cutting edge of domain. It happens, because where the higher technologies do come to India after a few years, so that creates a little bit of problems in the domain of electronics. Also in the domain of R&D in Indian industries and academic systems are actually low. I think let us not forget this aspect that research is not happening into the higher level in academic institutions or industries in India. It is actually concentrated on certain laboratories and institutions. Even IIT system, I will tell you, the ability to connect with industries and produce high-end research to suit the need of the industry is still far away. This is something that we need to close it over a period of time. And academic connect to industry and supporting industry is the need of the hour. And over the last few years, I am seeing the change happening because many of the IITs are mandated to do now to have the industry connect, create the incubation centers, understand and go around the industries to seek the problem statement from them and produce research focused on what is commercially needed for them to scale their business. So there will be a flow of money from industries to academia and vice versa. The flow of people also from academia to industries and vice versa. This will create what is required for the ecosystems to thrive on a business model. Business and R&D go together. I think this is a change we are also bringing about in Indian Space Research Organization as well. Recently, you would have heard about the space policy announced in 2023 policy and the space sector reforms, where we are trying to expand the economy of space activity. I think all through the last many years, it has been only government, the fund provider for Indian Space Research Organization. We were funded typically 13,000 to 15,000 crores a year, not a huge money as far as India is concerned. And if you continue in this mode, this will be the state of affairs. We will be still launching rockets, we will be still launching satellites, but overall economy of scale of activity will continue to remain at this scale. And we don't want it to be like that. We want it to expand substantially. We want to make sure space goes to much deeper roots and become applicable to much more larger segment of the community, and also create business opportunity and create more market demand. I think all will appear to be not technical to you, but I think all of you IIT people are equally good managers as well. They are not only technologists, they also know what is needed for the nation. I think you will understand that it is important to understand the economy of technology. And technology will grow only if the economy grows. It doesn't go itself. Technology doesn't grow as technology sake alone. It will need of the business and need of the community, need of running the economy, the driver of the technology. So we need to bring the space into the hands of common people. It cannot be remaining within the organizations like ISRO. We want to bring it to the industries. We want to bring it to the startups. Help them to build new systems for the future. And allows private actors to come and operate in space sector very freely for everything, rocket building, satellite building, applications launching, creating markets, creating applications to support various decision makers and various business houses. I think this is happening now, and ISRO is going to focus more and more on the advanced R&D, and then provide this knowledge of R&D into the hands of the private players so that the ecosystem will grow. We want to make sure that there is private investment in space substantially than that was the past. So why I'm telling all of this to an academic institution like IIT is because there is an opportunity today for you to work in R&D in space sector, not for ISRO alone, for the entire space ecosystem. The emerging space actors will demand a lot of knowledge. They all lack possibilities of innovation, doing it in prototyping and understanding the possibilities. I was very happy to see some of the emerging space actors in space sector recently, like in IIT Chennai, where there is a new rocket company has been incubated. Possibly many of you know, it is Agnikul. They started as a small laboratory in the combustion lab of IIT. Now they have established a full-fledged testing facility outside the campus. Of course, that's a leased land of IIT Chennai, where they have tested the engine test facility. And they have recently done their semi-cryogenic engine, 3D printed engine testing. And another company, Skyroot Hyderabad, which derives a lot of support from previous ISRO DRDO scientists. We have one at Indian Institute of Science, which is called Bellatrix. They work on electric propulsion system. In fact, I was the one who gave them the first order way back in 2017. They have made their first electric propulsion thruster, and they are going to offer it for small satellite constellation. They established full-fledged design, testing facilities in Indian Institute campus, and possibly they are going to build it outside. And they are in the process of buying new land and establishing laboratories outside. I have seen in IIT Mumbai another startup company called Manastu Space working on solid propulsion, electric propulsion thrusters, and they are offering propulsion solutions for emerging satellite community. These are a few examples, and there are many more. Many more started in the application side, started in sensor making, started in deployers. So there are a lot of new startups, almost 200 of them in the recent past. I could say almost 200 such companies have come up with the various in the domains of space technology, and many of them with the support of faculty from Indian Institute of Science, Technologies, as well as other engineering colleges and institutions. So this is a new opportunity. You can help new people really who wanted to work in this domain. And I want to tell you that the research projects that we announced are small funded projects. They are not huge funded projects, but doesn't limit this within this. We have methods by which we can give you bigger projects if there are sufficiently strong case for it. So this need not be done under spot. I want to tell you that there are possible to handle these projects of bigger scale in a separately funded MOU mode. So absolutely there is no limit of funding that can be given if there is a good project that you can execute with the support of the students and faculty in a sustained manner and produce some tangible result. And this is the new mandate for ISRO. We want to connect with academia, we want to expand our research grants and possibilities in the days to come. Take it as an initial beginning and opportunity that I'm very happy that some response projects are running very well in IIT Roorkee, and some good results have come out of it. So advice today is to go through this, see our website and understand which all domains are really possible and engage with us. I think we will be very, very happy. And I want to thank especially the chair of the STC cell, our capacity building program office, and the directors of ISRO for engaging with IIT Roorkee for such a great event. I'm really pleasantly surprised to see the interest in IIT Roorkee. I can tell you that I have not explored most of the system very well yet. I think I am on a running spree to find out more possibilities in this country in various institutions. Let me do that over a period of time and create what is required for the energy required for enhancing the connect between academia and research as well as the research what is happening in ISRO system. Possibly you know that there is an academic institution within ISRO also, Indian Institute of Space Science and Technology. It's a very small institute focused on space technology. We have just 100 faculties and 1,000 students doing specifically some domains of space technology. And today we know that space technology is limited to some certain domains. It's actually a wide domain area. There are almost 22 plus departments here. I believe it's 22 plus. So multidisciplinary way of solving problems is the most appropriate thing, and I am very happy that at least 14 of your faculty members from various departments are joined together to work in this space cell. And I'm sure you will take up problems, work out a multidisciplinary approach to address them, produce results in a timely manner, and this is something that we look forward to. Unfortunately, ISRO is a very time-bound acting organization, and we will put schedules. We will review it on a period of time, and we will also look for tangible outcome over a period of time. So this is something very difficult with us. So I will also advise you to work on programs that cannot be open-ended. It is actually well defined over a period of time that you can deliver, and we will be very happy to connect with you and look forward for solutions that will support the space ecosystem of this country. And thank you so much for giving me this opportunity to come here, interact with you, and know more about IIT Roorkee. I think it will be a journey that will take it further for much more stronger engagement.